Hello, this is Jeno Sheeba from Neet Gateway, part of Physics Department. Today we are going to see the chapter Gravitation. This is in the Standard 11, Neet chapter number 6. See, what is meant by gravitation? Gravitation is nothing but there is a force of attraction between the two objects. Okay. Here is something, that is apple is falling from the tree. Earth is having some gravitational pull. It is dragging the apple towards downwards. Okay. So there is a force of attraction here, that is known as gravitation. Gravitation is nothing but there is a gravity. Today's plan, we are going to see in the gravitation, we are going to see we are going to learn two things here: acceleration due to gravity as well as variation of g with altitude and depth. See, first acceleration due to gravity. Okay. Before that, we will learn what is, we saw in the previous class, universal law of gravitation. We know that what is meant by universal law of gravitation. We know that F is directly proportional to m1 m2. See, what is meant by m1 m2? I told you, take two objects. We are taking here two objects. This is two objects. This is having mass m1 and this one is having mass m2. Okay, two objects. If there is two objects, there is a force of attraction between the two objects. So there is a force of attraction here. This mass also, it is having the force of attraction. So force is directly proportional to the mass m1 and the mass m2. As well as I am going to keep this distance as an r. Okay, this distance as an r. So what is r here? If you are taking two objects nearer, the force of attraction between this is high. Attraction is high, and if I am taking the object in the longer distance, farther distance, the force of attraction is here, r is less, force of attraction is less. So I am saying here F is inversely proportional to 1 by r square. Okay. So when we increase the distance here, r is nothing but distance. So when we increase the distance, the force of attraction is less. So force of attraction is less, so inversely proportional. So we are saying in the Newton universal law of gravitation, F is directly proportional to m1 m2 divided by r square. Okay, that is nothing but each and every object in the universe, it is having attraction. Okay, here that is a product of two mass and the square of the distance between the square of the distance here. Okay, so we can write, we want to remove the proportionality here. So I am going to write F is equal to G m1 m2 divided by r square. Okay, G is nothing but gravitational constant, that is a constant value, gravitational constant. This is a constant value and it is having the number as 6.67 into 10 power minus 11 Newton meter square kg minus 2. This is the gravitational constant value. Okay. So F is equal to G m1 m2 divided by r square. This is nothing but Newton universal law of gravitation. Our aim is to find here now acceleration due to gravity. I am going to take this formula. Okay. We saw now acceleration, the force between the two objects is F G m1 m2 divided by r square. Okay, according to Newton's second law, according to Newton's second law, we know that F is equal to ma. F is equal to ma. Okay, and I am going to write here F is equal to m into g. G is nothing but this is also acceleration. here in the gravitation chapter we are going to denote g as an acceleration. This is same only. Acceleration due to gravity. So we are writing here A is equal to G. I substituted here A is equal to G. So we are going to use this formula in gravitation. F is equal to mg. Okay, F is equal to mg. Now from this we can calculate what is G. Our aim is to calculate now what is G value. Acceleration due to gravity G value. So G is equal to F by m. F divided by m. G is equal to F divided by m. Okay. Now consider an earth. Okay. I am going to keep the mass of an earth as me. Okay. Mass of an earth as me. And here our aim is to find the acceleration due to gravity for this particular object. This is an object. I am going to keep the object above, that is on the surface of the earth. So I am keeping here in this surface of the earth here. Now this is in the center. We know that gravitation is the central force. Central force is nothing but we want to measure, always we want to measure from the center to the another object center. Okay. So I am going to measure, this is one object, center to the center. Okay. I am going to keep this radius as an RE. Earth radius as an RE. Okay. Now we want to calculate the acceleration due to gravity, that is G. Okay. So we can write now force equation. This is a general Newton's law, general form, Newton universal law. For this acceleration, to find the acceleration due to gravity, I am going to write F is equal to G. Okay. We are having here G. M1, I am going to take the mass of an earth as an me. So mass of an earth is an me. Okay. This small mass above the surface, okay, that is on the surface, I am going to take, this is an m. Okay, this is m. So this is m divided by, I took here the radius of an earth as an re. So here that is square of the distance. So re square. So this is the formula for the force due to acceleration due to gravity G. Okay. Now we can write here G is equal to, substitute in this equation, G is equal to Gme m divided by Re square, that is force, and here we are having one mass, that mass m. Now cancel this mass. Now G is nothing but Gme divided by Re square. This is the acceleration due to gravity G when the object is placed on the surface of the earth. Okay. We are having the constant value for G. G is nothing but G is equal to 9.8 meter per second square. Okay. We know the constant value for gravitational constant. G, what is the gravitational constant? G is equal to 6.67 into 10 power minus 11 Newton meter square kg minus 2, and mass of the earth, that is a constant value. So we can write me is equal to 6 into 10 power 24 kg. Mass of the earth is 6 into 10 power 24 kg. And radius, R is nothing but, Re is nothing but radius of the earth. That is also constant only. So Re is equal to 6.4 into 10 power 6. 10 power 6 meter. Okay. Now if you substitute in this equation, you will get acceleration due to gravity is 9.8 meter per second square. Okay. So this is the value we got here. We are going to use this formula in the next slides and all. Now our aim is to find variation of G with altitude. Altitude is nothing but, that is height. Okay. Or else we can say this is an acceleration due to gravity above the surface of earth. Above the surface of earth. So now we are going to find when we are going to keep the object above the surface of the earth. I am going to keep the object here. Okay. Now I am going to keep the object here above the surface of the earth. Our aim is to find now for this particular object what is the acceleration due to gravity when it is kept above the surface of the earth. Okay. So here I told you gravitation is a central force. So always we want to measure from the center to the next object center only. Keeping mass as an ME, okay, earth mass as an ME, and here this height as h, okay, above the surface this height as an h. Now we know that the radius of earth we took here as an RE, radius of an earth as an RE. Now we want to calculate from the center to the next object center only. Okay. So from this to this, what is the acceleration due to gravity? When the ball is, this object is falling down, what is the acceleration due to gravity we want to see. So what is the distance now from this place to here? What is the distance? We can take this distance as RE plus h. This total distance as an RE plus h. Okay. Now we are going to see. We know that we saw in the previous slide, we saw G is equal to, okay, acceleration due to gravity, G is equal to GME divided by R square. Here we are taking the radius as an RE plus H. So I am going to write here the radius RE plus H the whole square. Okay, RE plus H the whole square. Now calculate the G. Now G is equal to GME. Okay, this is of A plus B the whole square. So we want to expand this equation now. So A plus B the whole square is equal to A plus B the whole square is equal to A square plus B square plus 2AB. Okay, now I am going to expand this equation. RE square plus H square plus 2A is nothing but RE and B is H. Now we are going to see here H is small when compared to RE. Why I am saying like this means we know that the radius of the earth is very large when compared to the object height. We are keeping the object nearer to the earth only. But the radius of the height is, the radius of the earth is very large. So I am saying here RE is very large, that is radius is very large when compared to the height of the object. So I am going to neglect the higher power of the H here. Okay, higher power of the H. So we can write now G is equal to GME divided by RE square plus 2REH. Okay, 2REH. Now this can be written as G is equal to GME divided by, I am going to take this RE square out. So RE square. So if you are taking RE square out, we can write 1 plus 2 into REH divided by RE square. Okay, now this RE and this square get cancelled. So now this can be written as G is equal to GME RE square 1 plus 2H divided by RE. Okay, now I am going to take this denominator to the numerator. So it becomes as a negative sign. G is equal to GME divided by RE square. Taking this in numerator, 1 plus 2H RE minus 1. Okay. Now by binomial equation, you studied in the mathematical expressions. By binomial equation, we know that 1 plus x, the whole power n is equal to 1 plus nx. That is, I am going to expand this equation now. This is 1, this term is x, 2h by re is, I am going to take that as an x, and n is nothing but n is equal to minus 1. So we took here n is equal to minus 1, okay, and what is x? X is equal to 2h divided by re. Now we substitute in this expression. This is just a formula, this is a binomial expression, okay, mathematical expression. Now you substitute in this equation, g is equal to gme divided by re square and 1 plus x, 1, okay. Here we are having, for n we are having minus 1. So I am going to put here minus symbol, minus, and x is 2h divided by re. 2h divided by re, okay. Now this can be written as g is equal to g, here we are finding variation of g, altitude, height. So I am going to represent this as a g of height, g of h, okay, height, we are finding height. So g of h is equal to g, this is g, what is g? We found out g as n, g is equal to gme divided by, in the acceleration, the previous slide we saw gme divided by re square is equal to g, that is an acceleration due to gravity. So I can write this as a g, 1 minus 2h divided by re, okay. This is the formula we got for the acceleration due to gravity when the object is placed above the surface of the earth. This formula is used in many problems. They asked in the previous year question papers also. They asked when the object is placed in the above the surface of the earth, find the calculation. We want to find some numerical terms and we want to derive by using this formula only. So this is an important formula. G of height, that is height, is equal to g into 1 minus 2h divided by re. Now we are going to find variation of g with depth, okay, or else we can say this is an acceleration due to gravity below the surface of earth. Below the surface of earth, that is below, that is we are going to find the depth, okay. Consider an earth, okay. I am going to keep an object below the surface, taking this distance as d, okay, this distance as in d. This is one spherical part. I am going to take this as a spherical part. Earth, okay, earth center, this is a central force, so we want to measure from center to the earth, taking the radius as an re, okay, and mass of an earth is an me, and this small object mass is an ms, okay, small sphere, that is mass is an ms. Now what is this distance? This is re and this is d, okay, and what is this distance now? That is re minus d. Our aim is to calculate this distance from this position. What is the acceleration due to gravity? When this object falls down, what is the acceleration due to gravity for this object only? So re minus d. This is re minus d. Now imagine that earth is having the density, that is constant density. Earth is having constant density. Density is constant for the earth. Density is constant. So for the whole earth the density is constant. I'm going to say here this density, that small sphere density as well as the whole density of earth is also constant only. That is, density we are going to represent the symbol as in rho. Okay, density symbol as in rho. Rho S is nothing but small sphere. Okay, is equal to rho density of earth. Yeah, this can be written as rho S is equal to rho E. Earth is an E. Okay. Now we know the formula for density. Density is equal to mass by volume. Density is equal to mass by volume. Now I am going to write here density. Density is rho mass by volume. Rho is nothing but mass by volume. This is small sphere. I am going to represent here also S and here also S. Is equal to this density of air. That is, density is equal to mass by volume. Okay, earth. So I am going to represent E. This is also E. Okay, mass by volume. Now I told you that this is spherical in shape. Okay, this is the object we are keeping, that is sphere we are taking is in spherical in shape. So volume of sphere, what is the volume of sphere? Volume of sphere is nothing but V is equal to 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. Now you substitute in this equation, that is 4 by 3 pi r cube. That is ms divided by 4 by 3 pi r. We took the r for the small sphere as in, what is r? Small sphere, the r as in re minus d. So re minus d the whole cube is equal to, here we are having me, okay, mass of an earth. So me divided by volume of sphere. Okay, it is spherical in shape. So volume of sphere is 4 by 3 pi r. We took the radius of an earth as an re. So I can write this as an re the whole cube. Okay, re the whole cube. Now 4 by 3 here, 4 by 3 get cancelled and pi get cancelled. Okay, now ms divided by me is equal to, I am going to take this numerator to this side, denominator to this side, re minus d the whole cube divided by re cube. Okay, this can be written as now ms is equal to me re minus d the whole cube divided by re cube. This is one equation. This is equation number 1. I am keeping this one as an equation number 1. Now we know what is the acceleration due to gravity. G is equal to, this is a general one only, G is equal to G, capital G, that is gravitational constant, and ms we are finding for the small sphere only. So ms, mass of the small sphere is in, small sphere is in, we are taking as an ms. So ms divided by, and this radius, we took the radius for the small sphere as an re minus d the whole square. Formula is square of the distance, so whole square. Now we substitute here ms for this, substitute this equation here ms. Now G is equal to G ms, that is me re minus d the whole cube divided by re cube. Okay, divided by re cube. So divided by re cube, here we are having re cube and here we are having re minus d the whole square. Okay, re minus d the whole square. Now this whole square and this get cancelled, cube get cancelled. So we are having only one part, RE minus D. Now this G can be written as, this is nothing but variation of G with depth. So I am going to represent this is an G of D. Okay, depth as an G of D. So G of D is equal to G M E R E minus D divided by R E Q. Okay, divided by R E Q. Now take this R E outside. Now this can be written as G M E R E. So 1 minus D divided by R E divided by R E Q. Now this get cancelled and here we will get square. Okay, this is the expression G of D is equal to, we know that G M E divided by R E square, it is nothing but there is an acceleration due to gravity. So we can represent there is a G, acceleration due to gravity as a G. So G into 1 minus D divided by R E. So this is the expression for variation of G with depth. This is also will solve in many problems. Okay. Now move on to the next slide. Problem number 1. This is asked in the Neet previous year Neet 2020. Okay. What is the depth at which the value of acceleration due to gravity becomes 1 by n times the value that at the surface of earth, keeping here the radius of an earth is equal to capital R. So they are asking D value. D is equal to what? Okay. Solution now. D value, we don't know what is D value. We need to find the D value. And here G of D is equal to, they given here 1 by n times. Okay, if they are giving 1 by n times or 2 times or 3 times like that, we want to equate the two equations. That is 1 by nth term value of surface of the earth. Okay, acceleration due to gravity, keeping the acceleration of due to gravity of the surface of the earth as in G. Now we know the formula for acceleration due to gravity for depth, that is G 1 minus D divided by R is equal to 1 by n G. Now this G get cancelled. Now this can be rewritten as, I am going to keep this term here, I am going to take this term in this side. That is, here we are having positive sign, so 1 minus 1 by n is equal to, here we are having negative sign, so when we go to this side it becomes as a positive sign, D divided by R. Okay. Now multiply, cross multiply this one, n minus 1 divided by n is equal to D by R. Our aim is to calculate what is D. Okay. Now cross multiply this one, R n minus 1 divided by n is equal to D. So we got the value for the depth, R is equal to, that is D is equal to R into n minus 1 divided by n. Now we are going to see the problem number 2. At what height? So they are asking the height, h value, h is equal to what? From the ground will be the value G be the same as that in 10 kilometer deep mine below. So they given the value of D as a 10 kilometer below the surface of earth. Okay. So they given two parameters here, above the surface as well as below the surface. So solution, so if they given the two parameters, we want to equate the two parameters. So G of H is equal to G of D. G of H is equal to G of D. You know the formula for G of H. We know that G 1 minus 2H, okay, 1 minus 2H divided by R. This is the formula when the object is placed above the surface of earth at some height, okay. And for depth, when the object is placed in the earth, when the object is placed below the surface of the earth, we are having formula we derived in the previous slide. G 1 minus D, depth. So I am representing here D, that is D divided by R. Okay. Now this G get cancelled and 1 get cancelled. We are having here 2H divided by R is equal to minus D by R. This negative sign get cancelled and R get cancelled, having now 2H is equal to D. They given the value of D as an 10 kilometer, okay. So 10 kilometer, we can substitute that one. 2H is equal to 10. Our aim is to find what is the height. Height, at what height from the ground? What is the height value? So H is equal to 10 divided by 2, 5. So H value 5. So the answer is 5 kilometer. So answer is 3. 5 kilometer. Okay. Now problem number 3. This is asked in Neet 2017. Okay. The acceleration due to gravity at the height 1 kilometer. So they given the height value as an 1. Okay, 1 kilometer. Above the surface is the same as that of the depth D below the surface of earth. So here also first we want to think what is given in the question. Here they given in the question two parameters, that is above as well as below. If they given like this, you want to equate the two parameters. Okay, you want to equate. So given solution given, they given what they given, height is equal to 1 kilometer. Okay. Now two parameters are given, so we are going to equate the two parameters. G of H is equal to G of D. This is like previous problem only, problem number 2. We know the formula for G now. G, acceleration due to gravity at some height above the surface of the earth. So 1 minus 2H divided by R. When the object is placed above the surface, the formula for acceleration due to gravity is G into 1 minus 2H divided by R is equal to G. For the depth, the formula is 1 minus D divided by R. Okay. Now this G get cancelled. Now this can be written as 1 get cancelled. This can be written as minus 2HR is equal to minus D by R. This negative sign get cancelled and R get cancelled. So 2H is equal to D. The given value, they given the height of the height is 1 kilometer. So 2 into 1 is equal to D. They are asking the depth value only, D value. So we found out now the D value. D is equal to 2 kilometer. Okay, this is very easy question. This is asked in Neet 2017. So what is the option here? Option is 1. D is equal to 2 kilometer. That's all about the session. Hope you understood. Thank you.